No, I'm not. Okay. So, bond enthalpy. Sometimes a substance isn't even in one of those tables, like sulfurous acid for some reason. So, what do you do if you don't have an enthalpy of formation? You use bond energy. So bonds tie atoms together. You put energy in to pull the atoms apart. So what we can do is we can get average bond energies. Okay? This is only ever going to be a rough approximation because this assumes that all carbon-hydrogen bonds are the same, but they're not. Carbon-carbon bonds aren't all the same. Carbon-nitrogen bonds aren't all the same. They change slightly with every molecule. Every molecule, the bonds are unique to that molecule. So when we do this, you're only going to get an okay answer. It's never going to be perfect. Okay? And you have to keep in mind that if you have multiple bonds, it's going to be different. So a carbon-carbon single bond is 348. A carbon-carbon double bond is 614. A carbon-carbon triple bond is 839. Okay. Likewise, nitrogen-nitrogen single bond is 163. Double is 418. And triple is 941. Oxygen single bond is 146. Oxygen double bond is 495. Okay. And so on. So every bond is shaped by its environment. Like I said, they change from one element to from one molecule to the next. But also the way they're measured is, well, they take a methane molecule and they rip off one of the hydrogens, they get an energy. Then they rip off the next one, they get an energy. They rip off the next one, they get an energy. Rip off the next one, they get an energy, and then they measure it from there. All right, now here's the thing about these bond enthalpies. You do it backwards. It's reactants minus products. Okay, you add up all the bonds in your on your reactant side. You add up all the bonds on your product side, and then you do reactants minus products. It's garbage, but it's something you're just going to have to live with. So, for example, propane plus oxygen makes CO2 and H2O. So we look at our propane. We're going to have, well, let me bring it up. Okay. When you draw out propane, C, 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 H, 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 H. All right. So we look inside propane. We see 1, 2 carbon-carbon single bonds. And then we see 1, 2, 3, 4, 5, 6, 7, 8 carbon-hydrogen single bonds. And then for our other reactant, we have oxygen. There are 5 oxygen molecules, and each of those is a double bond. So we have 5 oxygen-oxygen double bonds. Each one is 495 kilojoules. So 495 times 5 is 2475. We have 2 carbon-carbon single bonds, 348 times 2. These numbers are coming right off this chart. So carbon-carbon single bond, carbon-hydrogen single bond, oxygen double bond, right? And then the 8 carbon-hydrogen single bonds, 413 times 8 is 3304. Carbon-oxygen double bond, we have 6 of those because there are 2 in each carbon dioxide molecule. So 799 times 6. Then 8 hydrogen-oxygen single bonds because there, again, are 2 of those bonds in each of our 4 water molecules, or 463 times 8. Why do I not? Okay, anyway. So we add up all of our reactants, we add up all of our products, reactants minus products. So 6475 minus 8498 gets us negative 2023 kilojoules. The actual enthalpy of reaction for propane is negative 2219.2. So it's off by about 10%. That is a lot. This is something that you use when you don't really have much choice, when you are forced to by circumstances. Okay, it's a rough estimate that'll get you where you need to go. So now you go ahead and try this one. Just to get you started, I'm going to draw out hexane C6H14. So hexane is carbon, 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 carbon. 8, 9, 10, 11, 12, 13, 14. Hydrogen, 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 hydrogen. All right. So now with that picture, you pause the video, you can count up all the bonds. All right, welcome back. So hopefully you have finished the thing. Oh, wait, no. Count up the bonds. Okay, you counted the bonds. And now let's go ahead. I'll remove the picture so that you can use the entire table to do the thing. All right, welcome back. So we look inside of our hexane. We have 1, 2, 3, 4, 5 carbon-carbon single bonds. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 carbon-hydrogen single bonds. So just for hexane, we have, we also have to balance the, okay. So hexane C6H14 plus O2 yields CO2 plus H2O. So 7 and 6. Nope, we're going to have to double this. So 2 of these, 12 of these, 14 of these, and then 24 plus 14 is 38. So 19 of these. All right, so that means with two hexane molecules, that means that we're looking at 10 carbon-carbon single bonds and 28 carbon-hydrogen single bonds. And then with 19 oxygen molecules, that means we have 19 oxygen-oxygen double bonds. Now coming over here, we have 12 carbon dioxide, so 24 carbon-oxygen double bonds, and 28 hydrogen-oxygen single bonds. Okay, so we look at our table. Carbon-carbon is 348. Carbon-hydrogen is 413. Oxygen double bond is 495. Carbon-oxygen double bond is 799. And hydrogen-oxygen single bond is 463. All right, so bond enthalpy, reactants, minus products. So, calculator. Well, this is relatively straightforward. That's 3480. 413 times 28. 11,564. 495 times 19. 94,005. We add those together. Plus 3480 plus 11,564. 24,449. And where would we round? Oh dear, we would have to round at the hundreds place. Yeah, because this would be limited to 3 sig figs, and we're changing operations. Okay, so in fact, it's 3480 plus 11,600 plus 9,410. Okay. And then we'd have to round again, so actually it is 24,500. And now we have 24 times 799 is 19,200. 463 times 28 is 13,000, but this is significant. So 13,000 plus 19,200 is 32,200. So 24,500 minus 32,200 is going to give us negative 7,700. It seems wrong, but I'm going to go ahead and trust myself. So let's see, minus 24,500. Yeah, 7,700. Actually, that actually seems okay. It's fairly high, but that's 7,700 for every 2 moles of hexane, which means that it's actually something like 3,850 for 1 mole of hexane, and that seems a little bit more on point. Okay, so that's how you do a bond enthalpy problem. You have to be careful about counting up your individual bonds. You multiply, you add, and then you subtract reactants minus products, because screw you guys. Seriously. All right, so that is it for bond enthalpies. And I'll be back in a few minutes to talk about heat of combustion. That one should go relatively quick.